guys, so this video is going to go over finding the domain and range of functions that are not always continuous, which in our case would be piecewise functions and rational functions. So with a piecewise function, you can tell from the graph and you can also tell from the inequality portions what your domain is going to be. So domain is from the left to the right. So if I start here on the left, I can tell that this piece is going to all the way to the left forever and ever and ever. So that would be negative infinity up until negative 2. So this would be x is less than negative 2 around this first piece, right? Not including negative 2. But if you look, the next piece of the inequality does fill in the blank for negative 2. This piece of the piecewise function would be x is greater than or equal to negative 2. So if I were to draw a number line and I were to shade both of those on the same number line, everything would be shaded. Everything to the left of negative 2, including negative 2, and everything to the right of negative 2. So most of the time, the domain of a piecewise function is going to be all real numbers. So I'm going to encourage you to start looking for that fancy R. That fancy R is the symbol for all real numbers, and it's just another way of saying negative infinity to positive infinity. Alright, so range is a different story with piecewise functions because typically there are gaps of blank space in between the different pieces of a function. So we always start at the bottom, right? So this does have an arrow pointing down. So in this case, this is going to be negative infinity. But if you look, it only goes up until negative 1, and it does not include negative 1. So because I have multiple pieces, this is going to start to look a little funky. Again, pretty much it's going to be like a multiple choice situation, and so you just have to pick the right choices. But if I'm doing the range for this, it's negative infinity up until negative 1. So that would be the same thing as saying that my y's are less than negative 1, which if I write an interval notation would be negative infinity to negative 1, and there would be a parenthesis on the negative 1. Because there's an open circle, negative 1 is not included. All right, then I have a gap. And so the symbol that we use in math to tell people that basically we're making a list, but they all belong to the same answer, is I'm going to use this like kind of big looking U. And that's just a symbol that we use whenever we have multiple answers for the same problem to let people know that this is another part of the graph, it's just separated. Alright, so then I would basically do domain and range all over again, or at least the range part, and only focus on the top piece that I haven't covered yet. So remember, we go from the bottom to the top. So the minimum or the bottommost piece of this graph is positive 1, and then everything above it. This piece tells me that y's are going up. So that would be y's that are greater than or equal to 1. And if I were to write that as an interval, that would be the same thing as 1 to infinity. A bracket on the 1 because that is a closed circle, so it does include the number 1. All right, so the main thing with piecewise functions is to understand that there's going to be situations where you have multiple parts of the range if your graph has huge gaps in it. All right, but remember the difference between when to use a parenthesis and a bracket. All right, range for domain and range for rational, we're going to do a little bit different because we can use the equation of a rational function to figure out where the vertical asymptotes, horizontal asymptotes, and holes are at. We're going to write our answers a little bit differently. So when the question asks you for the excluded values, it's talking about the domain, which means you're looking for a vertical asymptote or a hole. All right, so in this particular graph, I have two excluded values because this looks like I have a vertical asymptote here, when x equals 0, and I also have a hole when x equals 2. So you can just list 0 and 2 are the excluded values. If you're going to write the domain, what I would do is use the all real numbers symbol. There's usually a bar that comes after that. X cannot equal 0 or 2. So basically that's the shortcut. Instead of writing it like this, because for a piecewise function, we have like a huge gap in between our pieces, but when we have a rational function, there's not a huge gap. It's just one number that we have to skip. So it is negative infinity to positive infinity, except for those two numbers specifically. Everything else is negative infinity to positive infinity for the domain. So we can kind of make it a little bit shorter by just stating which numbers we have to exclude from the domain. All right, you will get the question wrong if the IXL asks you to write the equation. If you just put the number, IXL is going to mark it wrong. The equation of a vertical asymptote is written in the form of x is equal to the number where the asymptote is at. So in my case, it would be x is equal to 0 because that's where I have a vertical asymptote. The horizontal asymptote is y equals. And so this looks like I have a horizontal asymptote at 1. So my equation is y equals 1.